In this unit, we will be trying to take and classify matter in terms of whether or not a substance is pure versus a mixture versus the phase of matter, whether it's solid, liquid, or gas. There are three common states of matter that we will be considering in this class. The first type is a solid material. There are two different general types of solids. There are crystalline solids and amorphous solids. For the moment, we're going to focus in on crystalline solids. Crystalline solid has a regular repeating pattern for the arrangement of the atoms within the material. The atoms are essentially touching one another. There are small amounts of empty space that are not occupied by atoms, but in essence, the solid phase is pretty incompressible and its shape is very fixed. The liquid phase is a little bit less ordered. There are close contacts between the atoms, but the atoms are able to move around and change their position so that there is no longer a regular repeating pattern associated with the atoms. And the liquid takes the shape of its container. It's a fluid, and it will flow, so it can be poured from one container to another, but it tends to be pretty incompressible because there's very little space in between the atoms. The final phase is the gas phase. In this case, the atoms are no longer constantly touching one another, but they are in motion and they occasionally collide, but they tend to then bounce off of one another. So in the gas phase, the volume is mostly empty space with only a small portion of it being occupied by atoms or particles. And it turns out then that the gas phase is fairly compressible. By applying a pressure, you can change the volume of the gas by changing the volume of the container. The gas phase is such that the shape of the container can change pretty freely, and of course this is inherent in the types of intermolecular interactions. In order to classify matter, we have to first decide on what represents matter. Matter is a substance or something that has mass and can be affected by gravity. The main type of material that is not matter is energy. So things like light is not matter because it doesn't have mass. If a substance is considered to be matter, it can be categorized in one of two ways. It could be a pure substance, or possibly it could be a mixture. Those two things could be interconverted. If you have a mixture, you could physically separate the pure substances from one another, say by doing a filtration or some other type of separation, relying on, say, boiling points, distillation. Or you could take more than one pure substance and combine them and form a mixture. But pure substances cannot be separated by any physical process. And that is a key to identifying a pure substance. Mixtures can be combined or separated, and that is a crucial aspect of their physical properties, and we often in chemistry spend a lot of time studying what those properties are. If we have a pure substance, we can further categorize these as either elements or compounds. An element is a substance that has all the same type of atoms, whereas a compound on the atomic scale is where you have more than one element combined to form the unit. It is possible to take and introvert these two types of materials. So if you take two different elements, such as elemental hydrogen and elemental oxygen, provide a spark, you would get a fairly dramatic reaction, and the result would be water. Alternatively, it's possible to take liquid water and add energy to it in the form of electricity and separate the elemental components from one another and form gaseous hydrogen and gaseous oxygen. It is possible to classify the elements and organize this into what we know of as the periodic table. Again, an element is a substance that's comprised of all of the same types of atoms and generally cannot be simplified any further by doing some sort of chemical reaction. There are two general types of elements that we know of. There are the so-called metals. Metals tend to have a luster, they tend to be solids, they tend to conduct electricity very well. We have three common examples here. Gold, which tends to be kind of a brown colored metal, and tends to be a little bit different in its physical properties than, say, iron, which tends to corrode relatively easily, and especially in the presence of oxygen will rust, and that could be compared to, say, aluminum, which is kind of a shiny gray metal that is much less dense than gold. And so the physical properties highly depend upon the types of atoms that are present in the material. These can be contrasted with the so-called nonmetals. The nonmetals tend to have properties that are exactly the opposite of the metals. They tend not to conduct electricity. They tend to be gases or liquids or low melting solids. The two examples that we have here are carbon and sulfur. The sulfur is most common form is yellow sulfur. It is a very low melting material. The carbon is also found in a couple of different forms. There is graphite, the black graphite, which is fairly low melting, but it can be contrasted with another form of carbon, which you're probably familiar with, which is diamond, which is very high melting. We would like to know more about how the atoms are attached to one another as to why those changes occur in terms of the physical properties. The vast majority of the elements in the periodic table are metals, but certainly at this point we have well over 100 different elements, and depending upon how we combine them, we can come up with a vast number of physical properties which may be useful. Compounds are comprised of units where there's more than one type of atom in the formula unit. We have some examples shown here. For example, water has 3 atoms in it. There is 1 atom of oxygen combined with 2 atoms of hydrogen to form the formula unit. It turns out that this molecule has a distinct shape. It happens to be bent. That shape and the properties of how those atoms are attached to one another dictate the physical properties on the macroscopic level. That can be contrasted with another molecule which has three atoms, carbon dioxide. In this case, there's one carbon and two oxygens. Its shape is very different, and also its physical properties are very different. Carbon dioxide at room temperature is a gas. Water is a liquid at room temperature. We can compare these two molecules that have more than three atoms, something like ethanol. Ethanol is a liquid at room temperature, but its boiling point is significantly different than that of water. And even though it shares some of the properties of water. Likewise, ethylene glycol, again a similar molecule, but it tends to have a much higher boiling point and is sometimes used as an antifreeze. And then finally we have aspirin. Aspirin has a distinct shape associated with it, and how that molecule and its shape interacts with biological molecules can dictate how it acts as a pain reliever. If we have mixtures, we can further subcategorize these into one of two typical types. We can have homogeneous mixtures, sometimes referred to as solutions. These solutions can be solids, liquids, or gases. The term homogeneous has the prefix homo, which means the same. So this is a mixture that is the same throughout, or where the components are evenly distributed. Alternatively, you could have heterogeneous mixtures. The prefix hetero means different. This is a mixture where there are distinctly different regions of the material, and they can be identified usually fairly easily on the macroscopic level by looking at it, but sometimes one needs to use a microscope to see the inherent heterogeneity of the material. Some examples of mixtures that are found and you may be familiar with are, for example, one could make iced tea. And to make iced tea, you would take tap water, which itself is a mixture of water and some minerals. You might then add a tea bag. The tea leaves is essentially a very complex mixture, but some of the components of the tea leaves are soluble in the water and can be separated from the tea leaves by a tea bag, essentially a filtering process. If you then have your tea dissolved in the tap water, you can then further add some sweetener, some sugar, which then upon stirring you can then form your sweet tea. Alternatively, a heterogeneous mixture, an example of that is granite. Granite is a basaltic type of rock, oftentimes comprised of a variety of different pure substances that form grains or granules that can be identified using a microscope or possibly a magnifying glass.